right, guys, so again, when we take a compound that's in an aqueous solution and we dissociate it into its ions, we're going to separate it into the cation and then the anion, and you have to write the charges. If you do not indicate the charge, it is not considered an ion. So if you don't write the charges, the whole thing's going to be wrong. So I took AgNO3. I know silver is my cation, so I wrote Ag with a +1, and it's still an aqueous form. Nitrate was my anion. I have the -1 charge, still aqueous. I'm going to go to the next compound now that's aqueous, which I see is sodium chloride. So now I'm going to take sodium, that's the cation, so I'm going to write Na with a +1 charge, and that's aqueous. And then I'm going to write my anion, which is chlorine, and chlorine has a -1 charge, and that's aqueous. Okay, and now I'm going to continue on with my products. So here's my arrow. Now, silver chloride is a solid. And I told you that solids cannot dissociate into their ions. So I can't touch that one. I'm just going to bring down AgCl, solid. Can't touch a solid. So I can never break that down. So I'm just going to bring what I have down if it's a solid, liquid, or gas. The last product that I have is sodium nitrate. It is aqueous, so will that break down into its ions if it's in an aqueous solution? It will. So we're going to break down sodium, +1 charge, it's an aqueous, and nitrate, NO3, it's a -1 charge, and it is aqueous. Okay, so we had our compound up here, which was just our regular chemical reaction. What you did in these steps was dissociate aqueous solutions into their ions. And this step is called writing the complete ionic equation. What that means is when it says complete ionic equation, that means that all of my aqueous solutions are now shown as ions, and I can see every single one of my ions that's present in this reaction. So that's why we call it the complete ionic equation. Okay? So the first step that we're always going to do is we're going to write out our reaction, just like how you've always done it. Then we're going to take all of the aqueous solutions and dissociate them into ions, which just means we're going to separate the aqueous solutions into ions, which is what you did here. But that can only happen for aqueous solutions. It can't happen for solids, liquids, or gases. And so this is called writing the complete ionic equation. Now that you have your complete ionic equation, we want to simplify this. We want to look at the reactant side and compare it to the product side and see if there's anything that is absolutely identical to where we can cancel those out. So for example, I have Ag with a +1 and it's aqueous. If I look on my product side, I don't have exactly Ag with a +1 that's aqueous, so I can't cancel that out. Let's look at nitrate. I have NO3 with a -1 charge that's aqueous on the reactant side. Do I have that same thing on the product side? I do. NO3 -1 aqueous. Since we have the exact same thing on the reactant side and on the product side, those things can be considered what we would call spectators. These are called spectators. Spectators are ions that are present on both sides, on the reactant side and on the product side, but they don't help with a chemical reaction. So we want to try to cancel all of the spectators out. So NO3 with a -1 aqueous is also seen on the product side. Somebody cancel these out. I don't need them. They're not part of the reaction. I want to keep going. We have Na with a +1 charge that's aqueous. Do I see that on my product side? I do, right here. Same exact thing. So since I have the same thing on the product and the reactant side, that's a spectator. My job is to cancel out or eliminate all the spectators. So let's cancel out sodium ion. Okay, lastly, I have chlorine with a -1 charge that's aqueous. But on the product side, chlorine is in a bond with silver and it's a solid, so those aren't exactly the same. I can't cancel those out. So we had a reaction, we wrote our complete ionic equation. The next step we did was cancel out the exact same things, which is called spectator ions. Lastly, I'm just going to write out what I have left that I didn't cancel out. So if I look at what I have left, silver with a +1 charge, I'm left with silver with a +1 charge, aqueous, and I have left chlorine with a -1 charge that's aqueous. So chlorine -1 that's aqueous. And the only product that I made was silver chloride that's a solid. This is called your net ionic equation. So this is called your net ionic equation. Once you get here, you're done. But I want you to look at this equation for me and make sure that it makes sense to you. Would it make sense that on the reactant side, I have silver with a +1 charge reacting with chlorine with a -1 charge, and that creates or produces silver chloride that's a solid? It should make sense. So this net ionic equation, the reason that we do this, or the reason that we go through all these steps to figure this out, is because this is really the reaction that's happening in this double replacement reaction. So sodium and nitrate are just there to really help form silver chloride, okay? That's the whole point of writing a net ionic equation. We want to know what is truly the reaction that is taking place in some type of chemical equation. So again, I was left with silver and chlorine, and that makes silver chloride, and that is really the reaction that's happening in the reaction that we first started off with, okay? I want to do another one of these, and then we'll call it good, okay? So we'll do one more of these. Let's say that I gave you hydrochloric acid and let's do zinc 2 sulfide. So ZNS, and that would be another aqueous solution. And those are going to produce for us hydrogen sulfide, that's a solid, and then zinc 2 chloride, and that's going to be an aqueous solution. So let's just look at our reaction again. We have hydrochloric acid, and it's an aqueous solution, is going to react with zinc 2 sulfide, and that's also an aqueous solution. That will yield, or that will produce for us, a solid hydrogen sulfide, and then an aqueous solution of zinc 2 chloride. So this was our reaction that you were, let's say that I just gave you these, you found your products. I'm going to ask you, write the complete ionic equation. So our first step now is to write the complete, I don't know why I just said complete. Write the complete ionic equation. Okay, so remember that writing the complete ionic equation means that I'm going to take all of my aqueous solutions, I'm going to separate them into ions. So remember, I can't separate solids, liquids, or gases. So any aqueous solution I can separate, but any solids, liquids, or gases, I can't touch them, I got to leave them alone. So HCl is where we first started with. Let's write that one first. It's aqueous. I can break it into ions. So in this case, it's going to be hydrogen with a +1 charge, and that's aqueous, plus chlorine with a -1 charge, that's aqueous. My next solution was zinc 2 sulfide, so that's an aqueous solution, so I can break that one down. So I have zinc +2 charge, aqueous, plus sulfur with a -2 charge, that's aqueous. Okay, so those are my reactants. Now we have to do the exact same thing for the products. So hydrogen sulfide is a solid. Can I break that one down? Should be saying no. So I'm just going to bring H2S in solid form down. I'm just going to leave it alone. Need to keep it the same. But zinc 2 chloride is an aqueous solution, so I can break those down into ions. So it's going to be plus zinc with a +2 charge, aqueous, and chlorine with -1 charge, aqueous. Okay, so what shall I do now? Now I need to look at my complete ionic equation, and now I need to find all of the find spectators and cancel. Find spectators and cancel those out. So H with a +1, aqueous. Do I see that on my product side exactly? I do not, because hydrogen is with hydrogen sulfide that's solid form. Those are not the same thing, so I can't cancel those out. Chlorine with a -1 charge, aqueous. I see that exact same thing right here, so those can cancel. Those must be spectators. Zinc with a +2 charge, aqueous, is on my reactant side. I see that exact same thing on my product side, so that means I can cancel those. Sulfur with a -2 charge, aqueous. I don't see that exact same thing on the product side. I see sulfur bonded with hydrogen as a solid form. That's not the same thing. I can't cancel those out. So then lastly, we will write our net ionic equation. And our net ionic equation in this case would be H with a +1 charge, aqueous, plus sulfur with a -2 charge, aqueous, yields H2S, and that's a solid. And let's just look at our net ionic to make sure again that that makes sense. So we have hydrogen plus sulfur would make hydrogen sulfide. Okay, makes complete sense. That is a reaction that would happen. So that means this is really the reaction that's taking place in our original reaction with hydrochloric acid and zinc 2 sulfide. So this is really truly the reaction that's taking place. There is one problem, and that is I did not balance that reaction before I started. So now let me look at my net ionic equation. Is this net ionic equation balanced? It is not. So I have one hydrogen, but I have two hydrogens over here, one sulfur over here. So how can I make sure that I balance this equation? I'm going to add a 2 in front of that hydrogen. So I have two hydrogens, one sulfur, two hydrogens, one sulfur. You need to make sure, though, that those are balanced all the way through. Okay? Do not wait on your last step to balance it on this net ionic equation. Want to make sure that it's balanced all the way through. Okay? So, guys, I, again, will not be here on Monday, but I have some other things that are planned for you. Please make sure that you have asked questions. If you have questions about this, it would definitely help you. And I will probably also try to make another video doing some more examples for you to see this on Monday, okay? I will see you then probably on Tuesday. I won't see you on Monday. Have a great rest of your weekend, and have a good Monday. And again, if you have questions, let me know. Bye.